Hello everyone, this is our fourth educational based video, and as we have promised in our previous video wherein we have studied all the mathematics formula, before this we have posted a video about review of all second, third and fourth videos wherein we have studied the formulas of derivative, integration and trigonometry. Then in this video, as I have promised earlier, that we will be studying about support reactions or either SFD, BMD. But then before starting with that, we will need to clear some basic concepts. So these concepts are useful in the subjects like engineering mechanics, strength of materials. These subjects, engineering mechanics is a subject which normally first year engineering degree students has, and strength of material is the subject which normally automobile engineering, civil engineering, mechanical engineering this student has. So to start with the subject, we first need to clear out some basic things. So before starting with the video, students, please do like, share and subscribe to our YouTube channel, and please press the bell icon so that you will get the notification about all our upcoming videos. So let's start with the video. In this video, what we are going to study is about first thing, types of supports. So normally what all supports you have is, first is hinge support. In hinge support you have two types of unknowns, that is Fy and Fx, means vertical unknown and horizontal unknown. Then you have roller support, that is here you have only one unknown, that is vertical. Roller support can be shown either this way or this way. This is again elaborated like fixed roller and hinge roller. Okay, now there is one more support which is called as fixed support. Fixed support, you have three unknowns, that is vertical, horizontal and a couple, or you can call it as a moment. This particularly means there is a continuation. Okay, now these are the three main types of supports which you have to study. Students, in this video, firstly I have mentioned types of supports, then I'll be explaining about types of beams, and then we will discuss about types of loadings. So in these three modules I have particularly these notations. Somewhere in some of the authors or some of the books you will find they use this notations as Fy, somewhere you will find Va, Vb, and somewhere you will find this notations as Ray, Rax and all. So all those notations I have used here. So first video I have used Fx and Fy. Fx denotes horizontal force and Fy denotes vertical force, wherein M denotes couple, or you can call it as moment generated. Okay, now next type of thing we have to study is types of beams. So first type of beam is simply supported beam. Simply supported means one support is hinged and other is roller. So here there will be three unknowns, that is two for hinge, that is vertical and horizontal, and one will be for roller, that is only vertical. The next type of beam you have is cantilever beam. Cantilever beam means it is fixed at one end and free at other end. There may be a load concentrated at that particular node. Now this type of things you will see in the window, like where you see the windows, there's the top part which is called as chhajja, or you see the part above the door that is called as lintel, or you can call it as canopy. So these all things you see which are called as cantilever beams. Basically this is important in the perspective of civil engineering students. Okay, so in cantilever beam basically you will have three types of unknowns, as because there is only one support that is fixed. So vertical, horizontal and a moment generated. Okay, so these are the two types. Next type of beam is overhang beam. In overhang beam there may be more than two or three supports, but the last end or either of the end is not having any type of support. That means the difference between this overhang beam and the previous type of beam which we have seen, that is cantilever beam, is in cantilever beam only one type of support is there, but in overhang beam at least two supports are needed, and then thereafter the beam is again a cantilever type. Okay, so here you may have more number of unknowns, but in cantilever beam you have only three unknowns of fixed support. Okay, the next type of beam you have is continuous beam. Continuous beam means you may have starting with hinge support, and then there may be so many rollers, or you may have a fixed support in at the end likewise. The next type of beam you have is fixed beam. Fixed beam means the name itself denotes two supports are fixed, and in between there may be supports, there may not be, and there may be loading likewise. So obviously for one fixed support you will have three unknowns: vertical, horizontal, and moment. Now here you can note down that this unknowns I have denoted as V and H. V means vertical, H means horizontal, and this is the node. So HA and VA, and again MA I have denoted. Previously I have denoted as FY and FX. Okay. And the last type of beam which we have is, it is called as cantilever simply supported, or either it is again called as propped cantilever beam. That means one end is fixed and other end is roller one. So obviously here you'll have four types of unknowns, that is three for fixed, vertical, horizontal, and moment, and one unknown for roller, that is vertical. Okay. Now there may be some extra type of beam which we can study, that is a beam with internal hinge. So internal hinge is the point wherein you may take moment 0, that is either left side you take moment 0 or either right side you may take moment 0. That we will see in one of the video when I'll discuss about support reactions and all. Okay. Next type of beam which you have is double overhang beam. It's kind of overhang beam only, but here it is overhanging on both the sides, you can say both the ends. So this is all about our types of beams. That is total you have, these are the main 6 types, and sorry, there was a mistake here. I have denoted as 6 types, then let me denote this as 7th type, and you can call this one as your 8th type. Okay. So this total there are 8 types, in which 6 are very important, and this you can remember just for your knowledge. Okay. Now next thing we will see is about types of loadings which we have. So you can first remember is point load. Point load means it will be mostly a downward load. You can take upward as well if you have in your particular beam. There may be a couple. Couple means it is a moment. So what is the moment? It is the force into the perpendicular distance. So a moment may be anti-clockwise or it may be a clockwise moment. Then there may be a uniformly distributed load, or you can call it as UDL. There are two styles of showing. Either you show like this, or you may show like this directly a rectangle. So here I have shown one hinge support and one roller support. This is exactly same. So to convert this, see, UDL, or you can call it as uniformly distributed load, is a rectangular type of load. It is everywhere it is same. That is, it is called as uniformly distributed. So to convert this load into a point load, what you have to do, you have to just multiply by, like, to convert to find out this load, particularly length into breadth. So length is how much? L. Breadth you can call it as W. So the load is WL, and it is exactly concentrated at the midpoint. So my total length is L, so my midpoint would be L by 2. Then my next type of load is uniformly varying load, or UVL. Now in this particular type of load, this is a triangular type of load. Okay, that means a load is starting 0 from here, and it is having height, let's say W of value, or it can either way, this way. So to convert this particular type of load, it is a triangle. So what is the area of triangle? Half into base into height. So my base is L and my height is W. So obviously the area will be WL by 2. So that is what I have written here. I have mentioned here half WL. Similarly, see, half WL, and it is concentrated at the length L by 3. That is, total length was L. So L by 3 from where? It is L by 3 from right angle. So it's a right angle of the triangle. So L by 3 from here. So obviously remaining will be L minus L by 3. That gives you 2L by 3. Similarly, it will be L by 3 from right angle. Right angle in this case is here. So it will be L by 3 from here, and the remaining one will be this total L minus L by 3 gives you 2L by 3. So this is the method, or this is the way of converting a triangular load. The next type of load which you have, that is last type, is the bracket load. Brackets which you see, you have in your doors, or you may see in some shutters, or you may see in windows or somewhere, openings you can call it as. So there you see, this is a 3D diagram which I have drawn. You can see it very clearly. You may have screws fixed over here. So in exams, normally examiner gives you paper wherein you will find out this particular type of diagram, or this is called as a bracket load. So let's say I have drawn a particular simply supported beam. This total length is L, and let's say these points are A and B. So this point at C point I have a bracket load. The value of this particular bracket load is, let's say, W, and it is the length, this length, horizontal length is X. So to exactly convert, how to convert this load, so at this particular same point, this point name I have not given, so I'll just give it to night right now. I'll just give a name. Let's see, C is the point, this was the point C. So this particular, at the same point, this bracket load gives you exactly the downward load, that is W, and say this is going clockwise about that point. So clockwise load of value, this is a couple or moment, you can call it as, that is W into X. So this moment value will be WX, and then later on you can find out the support reactions, which I'll be explaining in next lecture. So student, this is all about our videos, and just share this video with your friends, your colleagues, and stay tuned with for our next video, wherein we will be uploading a video about support reactions and then about SFD BMD. So basically we will be explaining all the engineering subjects. I myself is a postgraduate civil engineer, so I'll be posting most of the videos depending upon civil, mechanical, automobile, all those subjects which normally students face difficulties. Plus I'll post all the videos about, yeah, the video about mathematics, all the formulas, how to solve all the questions and all. So thank you so much everyone, thank you so much, bye.